Joe Gallagher from Veritas Education, and this is the Understanding the Netbackup Catalog lesson. In this lesson, we'll take a look at the structure of the Netbackup catalog, both the flat files and the relational database. We'll review procedures to backup and recover the NBDB, and we'll talk a little bit about NBDB maintenance. Let's start by taking a look at the structure of the Netbackup catalogs. Netbackup catalogs store all of the crucial metadata about your backup environment and about the backups that you've performed. There's two types of files that make up the Netbackup catalog. There are configuration files, which are flat files. Sometimes they're text, sometimes they're binary, but they contain mostly configuration information about the Netbackup environment and lists of files that have been protected. The Netbackup database, the NBDB, is a Sybase relational database, and so some data about your environment and some image information is stored here. Generally speaking, anything that would benefit from the more robust indexing capabilities that a relational database brings to the table is information that has been migrated to the NBDB. When the NBDB first came out in version 6 in NetBackup, it used to really just have Media Manager information in it, information about your devices and tapes. In fact, we used to call it the EMM database, the Enterprise Media Manager. And with every version since version 6, additional information has been added to the NBDB. So we see that in addition to this EMM information, we also have the job database. We also have information about backup image headers. And that's important because when we talk about the image catalog in NetBackup, the image catalog really exists in two places. The header files are stored in the NetBackup database. That's a small bit of metadata about each backup image that contains the fragment information. And then the lists of files that are protected, the .f files they're called, or those are flat configuration files. So here's a closer look at the catalog components. This slide lists the NetBackup configuration files, and so these are all directories or files underneath the NetBackup catalog path, which is platform specific. You can see it at the top of the slide here. And this slide describes in general terms what you would find in each of these directories. It's not really information you need to know to be a NetBackup administrator. It's more kind of an FYI. As we've mentioned, the NetBackup image catalog is probably the big one on the master server, both in terms of its criticality and in terms of its physical size. It's usually far and away the largest catalog on the master. And this is all the information about the backups that we've performed, all the information we need to do restores. So this is critical stuff. And the image catalog, or the image database, people use different terms for it, is spread across two locations on the master server. The backup headers, which contain the backup ID and the fragment information, are stored in the Sybase database, the NBDB, and that again allows them to benefit from the indexing for faster catalog backups and faster reporting. The file metadata, what we call the file lists, or .f files, because that's the extension that these files have. These are stored as flat files. And the .f files are literally just long lists of paths for files that have been backed up. If you back up 100,000 files in a backup image, there'll be a .f file with 100,000 entries in it, one path for each file. And so this is the information that NetBackup needs to be able to support individual file recovery. And so you see on the slide here information about the exact paths where you can find these files stored. Backup headers are in the database. The file metadata is in these .f files. And the image catalog is organized by client and by time. So if you browse over there, you'll see separate directories for each client. And then within each client's directory, lots of subdirectories in Unix CTime. It's possible to import and export backup header information. Definitely not part of a standard procedure. It's usually only done in support of specific operations, such as a partial catalog recovery. Here we're mostly just doing as an example to kind of give you an idea of what these backup headers look like. And so we've got a Windows and a Unix example here. We've used the export command, the cat export, to export a header file for examination. It's basically the text information. Again, it's a small amount of metadata about the backup image. This is not what takes up all the space on the master server. It's those .f files that contains the paths that are being protected. That's what really consumes vast amounts of space on the master. Let's move on and take a closer look at the NetBackup relational database. This slide shows the relational databases that may be present on the master server. There will always be an NBDB on the master server, and there may be, depending if you're using these features or not, separate databases for NetBackup authorization if you're using NBAC, and the BMRDB if you're using bare metal restore. Those share the same Sybase instance, but they are separate databases. And then it's possible you may see the Op Center database on the master server. The Op Center database is a different Sybase database, and it's hosted on your Op Center server. Now, it's generally a best practice not to have your master server be your Op Center server, but to have that on a separate host, unless you have a really small backup environment, like a remote office with its own master server. Certainly, if you've got Op Center managing multiple masters, you really want to have a dedicated host for that. And as we've mentioned, the information stored in the NetBackup database when it was first deployed was just media manager information, but since then we've added all sorts of stuff: resource management data, image headers, image change logs, Oracle information for DARs, and also more recently Oracle information that supports faster cross-checks between the RMAN catalog, the job database that just got added very recently. So this is, again, an ongoing process where when the engineers take a hard look at NetBackup and they feel there's a certain piece of catalog data that's currently being stored as a flat file that would benefit from the more robust indexing capabilities that you get with the relational database, that data migrates into the NBDB. This slide shows the physical location of the NBDB components on Unix and on Windows. So the first part of the table here is where most of the database is located. The data files, the transaction log, and the main control file are all located in that top path. The path down at the bottom has two configuration files, which are really NetBackup configuration files that contain important parameters that NetBackup uses when it starts the database. Here's some examples of some NBDB-related commands that can be useful when troubleshooting. The first one, the NBDB ping, is just a way of going out there and, like it says, pinging the database to see if it's out there. Is the NBDB mounted, and is it alive? We're just checking to see if it'll talk to us. The NBDB admin-list shows where the components of the database are located. If you suspect that an administrator might have moved the database components from their default location to a different location, which is possible as long as you do it in a supported way, here's a chance to view where that stuff is located. The NBDB admin, where you turn on and off the auto start feature, can be part of specific troubleshooting scenarios. Normally, as soon as the NetBackup services come up, Sybase comes up, and the NetBackup database is automatically started. Disabling that auto start would allow you to start Sybase without putting the NetBackup database online, which would be a troubleshooting kind of thing to do. They give the example in the slide here of maybe we've got a corrupt database that needs repair. That's one situation where I might be doing something like that. Same thing really applies to the next two commands in the slide as well when they talk about using NBDB admin to stop or start the NetBackup database. Again, it's a way of shutting down the database but keeping the Sybase engine online to do other troubleshooting or maintenance activities. Here's some examples of some of those commands. First example, NBDB ping is just a, hey, are you out there? And then in this example, NetBackup database responds, yep, I'm alive and well. Second example, the NBDB admin-list just shows where the components are located. In this example here, all database structures are in their default location. Same commands, but now we're viewing them on Unix. NBDB ping, NBDB admin-list. The output is the same in Unix or Windows. It's just the path where the command is located that's different. In addition to the NBDB ping, another way of verifying that the NBDB is online is to check to make sure Sybase itself is running. This will show up in a Netbackup process listing, slightly different names depending if you're on Windows or Unix. In Unix, the process name is NBDBserve. In Windows, it's dbserve16. And it'll also show up in Windows services as the Netbackup Relational Database Manager. But that's Sybase. Here's a couple of additional utilities. Now, unlike the previous utilities we showed you, which sort of operated at the database level, these are commands that operate at the Sybase level, where I'm sending commands, to the whole Sybase instance. So, first example, how to determine if the SQL Anywhere database is running. If I want to stop or start Sybase manually, here's scripts that will do that. The last example, if I need to stop Sybase with force, if I think that it's run into a problem and it's stuck and I really just want to kill the process and restart it. And so again, these commands are not just affecting the Netbackup database, they're affecting the entire Sybase instance. In this next topic, we'll talk a little bit about catalog backup and recovery. This slide shows an overview of the catalog backup process, and if you've taken the standard Netbackup 5-day administration course, you may already be familiar with this, but just as a review, when catalog backups run, multiple jobs are created. There's a parent job that's created first, that kind of oversees the process, and then there are the child jobs, which do the actual tasks involved in protecting the Netbackup catalogs. And there's going to be 3 of these. The first child job is going to stage the database. What it's really going to do is a dump. It's going to take the contents of the Netbackup database and dump it to the staging path, which is shown here on the slide. Second child job comes along and backs up the NBDB data from that staging area. And then the third child job backs up the image catalog files and the rest of the flat configuration files in the Netbackup catalogs. Once all 3 child jobs have completed successfully, the parent's job, last responsibility, is to write the DR, the disaster recovery file, and if it's been requested, to send out an email with the DR file attached, and then if those tasks are successful, the parent job will exit with status code 0. We break down this process into multiple jobs specifically to assist in the troubleshooting process. What happens if something's not going right with catalog backups? Well, this way we have activities like dumping the database, separate job from doing the actual backups, so it helps us kind of narrow down at what point in the process are we running into problems. Also note that this staging directory uses some space on the master server, uses an equivalent amount of space to the EMM database, because it's all of its contents that are being dumped there, and that this information persists until the next catalog backup. So if you ever had an issue with, for example, database corruption, and you wanted to roll back the Netbackup database to an earlier known good version, you could use that information in the staging area for fast recovery without needing to use backups on disk or on tape. Here's an example of these catalog backup jobs running. Again, 1 parent job and 3 child jobs. Generally speaking, if the 3 child jobs complete successfully, the parent will also complete successfully. If one of the child jobs fails, then the parent job might fail, or it might be in the partially successful state. If you ever see a parent job fail but children are successful, all 3 of them, or a parent job status code 1 but all the children are status code 0, that usually means that something has gone wrong with the process of writing the disaster recovery file or emailing it out to the administrator if that's been requested. Because remember, that's the last task that the parent job has to do, besides just being a babysitter for the child jobs. Also notice what's shown on a slide here. We had a lot of image cleanup jobs exiting with status code 1 partial success. There's nothing wrong with those image cleanup jobs. This is just NetBackup's way of nagging you that you are not doing catalog backups. If you do not have a catalog backup policy configured and running, NetBackup gets upset because it knows how important that is, and so it forces all the image cleanups to return status code 1, and then when you investigate, you see that that's the reason why. Once the catalog backup policies are active and running, you'll see that further image cleanup jobs, job number 92 in this example, complete with status code 0, and they're all going to complete, with 0 from now on, now that I've got catalog protection running. This slide shows an example of catalog recovery. Now, just like we had multiple jobs created when we backed up the catalog, we have multiple jobs created on catalog restores. There'll be a parent and a minimum of 3 child jobs, and there might be more. If you're recovering a catalog when you've done incremental backups, then you'll see additional child jobs being created, 1 child job for each incremental that you're restoring from. And so the process that happens here is Netbackup locates first the DR file and makes sure the DR file is readable and that they can find all the media that are referenced there, tape or disk. Once the catalog restore is initiated, the parent job comes first and then the children. That's basically the reverse order that the database was backed up in. The Netbackup configuration files will be recovered first. After that, the NBDB backups will be recovered to the staging area, and then data will be loaded from the staging area into the NBDB using SQL scripts that are provided with Netbackup. It all happens automatically in the background. There are different Netbackup catalog recovery methods that are supported. The most common method, and the one that's strongly recommended in most scenarios, is to recover the entire catalog. So that means that the configuration files and the Netbackup database are all recovered, and basically the server that we're recovering this data to is going to look exactly like the master server did at the time of the last catalog backup when this process is complete. So generally speaking, that's what we want. Now, there may be some specific cases where partial catalog recovery is desirable. So we could recover just the configuration files only and not recover the NBDB. Maybe we're doing that because the NBDB is healthy, but the configuration files are not. A lot of folks will have the configuration files and the Sybase database on different volumes on the master server. And so maybe I've had a partial device failure, where one of these disks has failed and the other one is okay. You also sometimes see a strategy like this being used when folks don't want to recover the NBDB because they feel that a lot of the information there is not necessary. It's got all this device information and tape information about an environment that doesn't exist anymore. If we're talking about disaster recovery and the original site has been lost. So they would like to recover just the image catalogs and not bring back the EMMDB. Now, not doing that, you got to be very careful to make sure you're providing write protection for your tapes. Remember, NBDB tracks not just the tapes you have, but also their status. And so if I was not going to be recovering that, I can discover tapes by using robot inventory, but they would all be in the available state, even if they had data on them, potentially very dangerous. So I'd want to make sure that I set the physical write protect tab on all of those tapes. More detail about this in the referenced article, How to 113960. And the opposite is also possible. If I want to recover the Netbackup relational database only, and maybe my scenario here is, the image catalog pieces that are in the flat files, the .f files, are healthy, but the NBDB is corrupt. Maybe that's why I'm doing this. Remember, if you find yourself in that situation, that you can recover data directly from the staging area if that path is still healthy and accessible without needing to actually do a catalog recovery. Catalog recovery can be performed either from the console or from the command line. Generally speaking, the console is easier, although either one will produce an identical result. The wizard is run from the admin console. You select the host name of the master server. The wizards appear on the right-hand side, and then you select Recover the Catalogs. And the first question that the wizard is going to ask is, show me your most recent disaster recovery file. Now remember, these DR files are generated during the catalog backup process, and it's because of a chicken and the egg situation, really. Normally when Netbackup goes to do a restore, there's that important metadata in the NBDB, that header information that it needs. Small amount of info, but very critical. And that's true for catalog backups. But with catalog backups, this is a DR scenario we're planning for where maybe my master server just blew up and none of that information is available anymore. I need to have it somewhere separate to start this process. Because that's what the DR file really is. The DR file, if you took a look at it, is identical to the header file for your most recent catalog backup. So there's a path that gets specified in the catalog backup policy where these get written to. Ideally, that's some kind of a shared location or a location that gets replicated or FTP'd offsite. You also can email these DR files to your recovery site. And that can be a cute thing to do if you use, for example, a webmail service like Hotmail rather than corporate email, because maybe you're thinking, hey, if some big disaster happens and it knocks out the corporate email in addition to all these other problems, that's another way I have of getting at my DR file. Now, security restrictions won't always allow that sort of thing, but when it's possible to do that, it's a nice thing to do. So emailing the DR file to the recovery site is probably the easiest thing to do, but if you want to do replication, if you want to do FTP, if you want to do a purely physical method where you put a thumb drive with a DR file inside every box of tapes that you ship out, whatever it takes. Do whatever is easiest for you and compliant with whatever restrictions you have. It's really secure sites that sometimes have to use more physical methods. But at the end of the day, the most important thing is, if you're depending upon catalog recovery as your disaster recovery plan, you gotta have this file. It's the first thing the recovery wizard asks for. Show me the most recent DR file. And you don't have to keep a whole collection of them. All you need is the most recent file, even if it was from a differential incremental. That's okay. Just give Netbackup the most recent one. It'll be all set. Here's an example of partial catalog recovery. So again, maybe my scenario here is the NBDB is valid, but some or all of the configuration files are not. So I can do this from the catalog recovery wizard. I get an option on one of the screens here to just recover the configuration files. Or if I'm doing bprecovery.wizard, I get the same choice, where it tells me, hey, we'll recover the configuration files, and it'll give me a choice as to whether I want to do everything or if I just want to do the image or the policy information. I can be a little more granular here than from the console. And what will happen is the NBDB will not get overwritten and loaded, but we will copy the most recent information to the staging area for further processing. We'll need that in order to guarantee consistency because there'll be image information in there that will need to be exported. Here's an example of an NBDB restore scenario. So here the image catalog is okay, but the Netbackup database has had some corruption. Really bad, unrecoverable corruption. So bad that we can't even get the normal catalog recovery mechanism to work, which would normally be our first choice in this situation. So doing a bit more detailed procedure here, we're preventing Sybase Anywhere from starting automatically with the NBDB admin command. And then we're using the create NBDB-drop to basically blow away everything that's in the NBDB, all of this corrupted stuff that's messing us up, and to create a completely blank database, kind of the way it would look when the Netbackup was first installed. And then we're going to go ahead and manually start the Netbackup device manager, make the backup media available if we have to come from tape, and then use the bprecover command with a -r and -nbdb, and that'll cause Netbackup to recover just the Netbackup database. Now notice we've got that command is assuming that I have to recover it from a catalog backup. If I've got a good, healthy catalog backup in my staging area, I can avoid the need to do a restore. I can use the NBDB restore command to read the data right from that staging area and load it into the NBDB. Now there are some situations that can require additional steps in recovery. When it comes to Op Center, the process of Netbackup catalog recovery automatically restarts your job numbering. You'll begin again with job number 1. That's a safety feature because catalog backups in Netbackup are hot backups, which might be running at the same time as other backup jobs. And so there's a potential for job number collision in that situation. So just to be safe, Netbackup resets everything to 1 on the recovery. Now, if you're working with Op Center, that might be a problem because you might have historical job information that you're keeping for a long, long time, and you don't want duplicate job numbers. And so you can manually go in and edit the NetBackup jobs database in the catalogs and reset it to the proper value for the job number you want it to start with. Other thoughts, if you're using NetBackup access control, that sometimes adds additional steps to catalog recovery where we have to disable NBAC when we do the restore, and then we can re-enable it again afterwards. If you're recovering from a non-primary backup copy, NetBackup assumes it's recovering from the primary copy, which is the first copy that's created, but maybe I had multiple copies and the primary copy was destroyed by whatever terrible disaster happened, but one of the secondary copies is still available, and that's what I want to use as the basis for my restore. It's easy, just specify the copy number in the BP recover command. Now, if I'm missing my disaster recovery file, we stressed the importance earlier in this lesson of having that file available at the DR site. But if, lots of mistakes were made, and I thought that DR file was making it to the recovery site, and it turns out it wasn't, all is not lost as long as you have your catalog backups. From your catalog backups, you can import the DR file pretty easily. The biggest gotcha here is you have to have your catalog backups, and you have to know where they are. In a tape-based restore, you got to know which tape has your catalog backups on it. So as a best practice, know which tape has your catalogs all the time. Consider doing something like buying tapes from a different vendor for your catalog tapes so that they're a different color than all your other tapes, or using a different barcode range so that your catalog tapes all start with CAT or something like that. These are not bad ideas at all. You never want to be guessing about which tape has your catalog data on it in a DR drill or an actual recovery scenario. You want to know exactly where to go. See that tape over there, the red one? That's the one I need. And then last thought, from a tape-based recovery, after the master server is fully recovered, the tapes that were used will be frozen to protect them from being overwritten, because these are kind of the last known good configuration from the original production site, right? So NetBackup is kind of being a little extra careful of them. It's not really very likely they would be overwritten, but NetBackup is freezing them just in case. When you feel they're no longer needed, you can unfreeze them, or you can keep them frozen, which to be honest is what I would do. This is my last known good set of backups from the production site. Let's keep that stuff around, for a long time until I'm positive everything's okay. Here's an example of importing the DR file. Exactly how this command is used depends upon the location as to where your catalog backups were written. Basically, I'm just pointing this command to my most recent catalog backup, and I'm specifying a temporary location where I'm going to create the DR file. And NetBackup is going to import the DR file from the catalog backup pretty quickly. This is a small amount of information. This is not going to take a terribly long time to run. And so what I'm specifying here is a path on disk if it's basic disk, or if it's advanced disk or tape, I'm going to specify the media ID for that disk or tape. So in this case here, it looks like it was a basic disk. In this case on the C drive, which is kind of a ridiculous example. Please don't ever write catalog backups to your C drive in real life. I think obviously, that's a bad idea. They're just doing it here just to give you an example. Lastly, let's take a look at some maintenance tasks associated with the NBDB. BPDBM is the NetBackup database manager, as we've discussed in other places in this course. This command can be used to do a consistency check on the image catalog, and this compares the contents of the image catalog against the NBDB and allows you to view the output looking for database consistency errors. This is not the sort of thing you need to do on a regular basis. This is not something that should be running automatically as a cron job or task manager job or something like that. It's just an additional facility we have that would be used most oftentimes in an upgrade scenario. If there's a major architectural change to NetBackup, sometimes we'll want to get sure that the catalogs on the master are definitely in a healthy state before we move on to upgrade to this new version. We kind of learned from experience there with some of the complex upgrades we did, moving from version 5 to version 6 of NetBackup, that if your environment has got some small amounts of corruption in there, maybe they're not causing you any problems in your day-to-day life, but when you go to do an upgrade, especially when you're moving data from flat files to a relational database that's going to enforce data consistency, sometimes you really get jammed up on that. So generally speaking, for the regular NetBackup admin, you're only running this command when you're directed to by NetBackup support as part of a documented procedure, probably an upgrade. NBCC is a Veritas utility that confirms the integrity of portions of the NetBackup catalog. NBCC gathers environmental information, NetBackup configuration information, and NetBackup catalog information, and goes through and does consistency checks and processing. So this is a pretty detailed consistency check, and it's something, again, that you would normally only run if you're directed to, either by a set of steps in a procedure you're doing, like an upgrade, or because support has asked you to help troubleshoot a situation. As with other utilities we've talked about, this is not something that you need to do on a regular basis. Sometimes that'll seem like a good idea to people. They'll be like, well, consistency check, let's run this, once a month or so, just to make sure everything's okay. The problem is that the NetBackup catalogs, you can sometimes develop, little bits of weirdness or irregularities in there, information that doesn't need to be there. That isn't really a problem, isn't hurting anything, and is going to get cleaned up by NetBackup's normal housekeeping procedures. But when we go looking for stuff, NBCC raises a red flag about it. So the long story short here is, it's like doing a lot of unnecessary medical testing. You can get red flags being waved about stuff that isn't really a problem. And that more than anything else is why we say don't just run this all the time, only run it when you're directed to. When NBCC runs, either it's going to find no problems or it's going to find some problems. And what happens is we upload the output of NBCC to Veritas support for analysis, and if there are problems that are reported, first off, they may not require any action. Sometimes NBCC will flag stuff when support teams will analyze it and say, nope, don't worry about it. This is just not a big deal, and NetBackup's housekeeping is going to clean it up on its own anyway. In other cases, we may say, yeah, you know what, this is a problem, and we need to clean this up. So we're going to generate a repair file. And the repair file is something that you execute with NBCCR to fix whatever the inconsistency is, which was found in the catalogs. NBCCR, you'll notice big red warning down here at the bottom, only ever run this command in the direction of Veritas support. You pretty much have no choice because in order to run the command, you have to give it an SRA, a suggested repair actions, and you get that file from support. NetBackup provides a database administration utility which can be used to perform some maintenance tasks on the database. Some of these are things that might be done on a regular basis, like password changes, and some of them are the kind of thing where you might do it only ever once in a while or maybe never. Password changes in some environments are required. This is an internal password that NetBackup uses to access the database. Theoretically, you never have to change it because nobody ever knows what it is. But, there's some environments that say, listen, if there's a password, you got to change it every 90 days. I don't care who sees it and who doesn't see it. So, here's an easy way to do that. I can also manage my transaction logs from here, including mirroring them if I want to add another level of protection. If I ever needed to move the database from one volume to another, maybe because I want to put it on a different volume than the rest of the catalogs for space issues or for I/O performance reasons or for an additional level of protection, that this would be the supported way to go through and do that. There are also performance tuning that I can do from here and validation checks that I can do from here. So that option, it says database space and memory management in a big, busy NetBackup environment with a really big image catalog and lots of processing going on and 20,000 or more jobs per day. There are tweaks that support can recommend that you can make to the memory management of the database to improve performance. Usually this is only necessary in high-volume master servers. And typically, if you're thinking of even making a change, talk to support first and get recommendations, because these are very specific settings that we might want to change in order to improve performance. If we mess around with these things and we don't know what we're doing, it would be easy to just make things worse. Here's an example of the database administration utility on Windows. These are the same tasks that we perform on Unix. It's just that in Unix it's a MUI, menu-driven utility, and on Windows it's a GUI, a graphical utility. And we've also got a little bit of status about the database that we see visually here, which is kind of cool. But otherwise, in terms of the tasks that you can perform from here, the tasks are identical. In this lesson, we took a look at the structure of the NetBackup catalogs, the configuration files, and the relational database. We looked at how to back up and restore the database, and we talked about some common maintenance tasks associated with the catalogs.